Hello and welcome friends. In this new video we will discuss about another important useful comparison test of improper integral. The improper integration of c divided by x raised to n between the limit a to infinity where a is greater than 0, c is a positive constant, is converges if and only if n is greater than 1. Now friend, we know that this integral is converges at infinity. By definition, we write it as, we write integration a to infinity c divided by x raised to n into dx equal to limit capital X tends to infinity a to x c divided by x raised to n into dx. Let us call it as equation number 1. Now when n is equal to 1, first case n is equal to 1, then integration of c divided by x between the limit a to x into dx equal to c is constant, integration of 1 by x is log x, and between the limit a to x equal to c into log of capital X minus log of a equal to c into log of capital X divided by a. If we take the limit of this, therefore limit of this integration a to x c divided by x into dx x tends to infinity equal to limit of c into log of capital X divided by a x tends to infinity equal to c into, as x tends to infinity log is also tends to infinity, so this is an infinite limit as x tends to infinity. So it gives us that the integral is diverges for n is equal to 1. We write here it is a diverges for n is equal to 1. Now, when n is not equal to 1, the second case when n is not equal to 1, here integration of x raised to n. Then let us evaluate this part of this. When integration of this term x raised to n, we know that integration of x raised to n, what will be the integration? X raised to n means we can write it as c constant integration a to x raised to minus n into dx c into x raised to minus n plus 1 divided by minus n plus 1 between the limit a to x is equal to c into 1 divided by 1 minus n, 1 minus n between the limit capital X raised to minus n plus 1 minus a raised to minus n plus 1, or equal to c into 1 divided by 1 minus n, 1 divided by capital X raised to 1 n minus 1 minus 1 divided by a raised to n minus 1. Then limit capital X tends to infinity, integration a to capital X c divided by x raised to n into dx equal to limit capital X tends to infinity c into 1 divided by n 1 minus n into 1 divided by x raised to n minus 1 minus 1 divided by n minus 1. Okay, so let us consider as x tends to infinity. As x tends to infinity, look at this part, this goes infinity and this whole fraction will tends to 0. So as this tends to 0 here, a raised to 1 n minus 1, then this is equal to c divided by 1 minus n into minus 1 divided by a raised to n minus 1. We write this as c divided by n minus 1 into 1 divided by e raised to n minus 1. So this term will be finite for n not equal to 1. Okay, and this is for n greater than 1, when n is greater than 1. Now what happen if n is less than 1? If n is less than 0, suppose n is less than 1, we have taken n is equal to 1 already. Now let us discuss about n less than 1. See the limit of this. When n is less than 1, we consider it as a negative and we check it by taking particular values. So this is equal to limit x tends to infinity, x tends to infinity, c into 1 divided by 1 minus n into 1 divided by x raised to n minus 1 minus 1 divided by a raised to n minus 1. Now if we take n is equal to minus 1, negative, so you can see that this term will be 1 divided by x raised to minus 2, and x raised to minus 2, this is equal to x square, and as x tends to infinity, this will becomes infinity, right? So this infinite, this will be infinite. That means as n is less than 1, the integral is diverges, and for which values the integral is diverges? For n is equal to 1 it diverges, n is less than 1 diverges, and it is converges and finite only for n is greater than 1. Hence this shows that the improper integral is converges only if this n is greater than 1.